In this video, we will look at obstacles when modeling with workers. Therefore, we will look at an example that is already prepared. In this example, we can see 4 workplaces at which the worker processes the parts. We have already prepared further stations, which we will now include to our model. Then we add workplaces to the new stations. If we now start our model again, we will see that the worker is walking all the way around the conveyor to find his way to the station. To visualize the obstacles around which the worker has to walk, we can switch to the View ribbon and click on Obstacles, or simply press the O key. Now Plant Simulation shows a red bounding box around each obstacle. The distance between the bounding box and the material flow object is 0.4 meter. The bounding box of the conveyor is a rough approximation of the curve. Each material flow object is by default an obstacle to the worker. The reason for this can be shown in the Edit 3D Properties dialog of an object. So we open the Edit 3D Properties dialog of the station. Here we switch to the Graphics tab. At the bottom, we can now see that the obstacle for worker is set to bounding box. So the obstacle for the worker is defined through the bounding box of the station. What we could do now is to change it to None and click Apply. If we now show the obstacles again, you will see that for the station there is no obstacle. If we leave it like this, the worker could basically walk through the station. To showcase the graphics option, we need to do changes to the graphical structure of the station. To do so, we open the station in a new 3D window. 3D graphics will be explained in more detail in video 19. For now, we will just add a new element to the graphic of the station. Here we now add a cuboid to the structure of the station. This cuboid should represent a pillar, which is part of the station, and can serve, for instance, as a rack with add-on parts. Then we switch to our model. Now we change to bounding box and apply the changes. If we now again show the obstacles, we will see that the bounding box encloses the station and the cuboid. Depending on your needs, this might be desirable or not. So you might want to model that the worker should be able to walk through the gap between the pillar and the station, or not. If we want to model that the worker should be able to walk between the pillar and the station, we can switch to Graphics. If you now show the obstacles, you will see that the worker has place to walk through. When selecting Graphics, each individual graphic element of the station is defined as an obstacle for the worker. As you can observe within the station's bounding box, there are now 2 additional bounding boxes. Since we transitioned to graphics, each individual graphic element comprising the station will have its own bounding box. However, if one bounding box encompasses another, only the bounding box of the enclosing element will be displayed. We now open the station in a 3D window. We can spot a safety switch and a control panel at the front of the station. These 2 objects extend outward from the station, so their bounding boxes are not entirely contained within the station's bounding box. As a result, separate bounding boxes are used to represent them when displaying obstacles. To avoid this, we can simply select all graphics of the station and group the graphics. Then we need to additionally open the Edit 3D properties of the new group. Here we switch to the graphics settings and need to change the obstacle for the worker to bounding box. Then we can switch back to our model frame. If we now show the obstacles again, we will see that around the station is one bounding box. To showcase the two other options, we will add a new graphic group. Then we switch again to the 3D window of the station. Here we now add a second pillar to the station and assign it to the new graphic group. Then we switch back to our model frame. Here we can now see the new graphic of the station. If we show the obstacles, we can see that they have adjusted to the new graphic. Now we again open the 3D Properties window and switch to the Graphics tab. Here we can now, depending on our needs, modify the visibility of the newly added pillar. So currently the graphics are selected. However, you might use multiple instances of this station, and sometimes the second pillar might not be used. To achieve this, we now switch the visibility off. However, simply turning off the visibility will not remove the obstacle. To avoid this, we can use bounding box of visible graphics or visible graphics. You may have noticed in reality the worker would be able to walk under the conveyor. To make him able to do this, we can use a footpath. By adding a footpath, we can enable workers to walk through obstacles. So we are inserting a footpath under the conveyor. Make sure to insert it such that it starts and ends outside of the obstacle. If we now start the simulation, you will see that the worker is able to walk under the conveyor. And you will also see that he is walking through the gap between the pillar and the station. You might ask yourself now why the distance of the bounding box to the object is set to 0.4 meter. The reason for this can be explained by an example. So we are inserting two stations in our frame. As you can see, you have 0.4 meter distance from the first station to its bounding box and 0.4 meter from the other station to its bounding box. This makes in total 0.8 meter, which is usually a shoulder width. So a worker will get through this place, as long as you leave a little space between the bounding boxes of the stations. Or in other words, as long as the bounding boxes of the stations do not overlap, a worker will get through them. Let's assume that we don't want a worker to walk between the two stations, although there would be enough space for it. In such cases, we can use barred areas. We can simply insert them from the Edit ribbon. If we know the exact dimensions, we can insert them in the dialog. Or we just place them and then press the M button. Here we can now adjust the dimensions according to our needs. If we now show the obstacles, we can see that the bounding box of the barred area encloses the stations. We next want to create virtually a second floor where we place our stations. To do so, we select them and place them higher. Then we place a mezzanine. If we now show the obstacles, a window will appear that shows us that we have obstacles on two different levels. To get a better understanding of our model, for example, if a worker does not reach a certain workplace, we can show or hide the obstacles on the other levels. If we now start the simulation, we will get an error that tells us that there are workplaces which are on a higher level and can't be reached. To fix this problem, we can now simply insert stairs which raise to the same level. Then we have to remove a part of the safety fence to allow the worker to enter the mezzanine. We first open the graphic structure of the mezzanine by right-clicking on the mezzanine and selecting Show Graphic Structure. Now the mezzanine is the selected graphic group in the Show Graphic Structure. To find the graphic which we want to delete, we expand the mezzanine group. We can click on the individual childs to highlight them in the frame. This way we can find the group which contains the graphic which we want to delete. Since this is the whole side of the mezzanine, we expand it to find the specific section we want to delete. We can now either delete the group from here, or we can use a more simple approach. Therefore, we close the dialog. First we select the mezzanine, then we place the mouse cursor over the graphic we want to remove. Then we can simply press the plus button until only the demanded graphic is highlighted. By pressing the plus button, we basically traverse the graphic structure as shown before. Afterwards, we can simply delete the graphic by pressing the delete key. Now we can place our stair accordingly. If we now again start the simulation, the worker will be able to reach the workplaces. We now set the height of the stairs to 2 meters. Now we again show the obstacles. We can see that we have 3 different levels. So in cases a worker can't reach a workplace, you might have a look into the different height levels in your model. You might ask yourself now, how tall an obstacle needs to be that the worker could walk under it. If an obstacle is shorter than 2 meters, a worker won't be able to walk under it. Since the mezzanine we use is higher than 2 meters, the worker was able to walk under it. To demonstrate this, we will insert a second mezzanine and leave the height at 2.5 meters. If we show the obstacle, we will see that there is no obstacle under the mezzanine, except for the legs of the mezzanine. We now set the height to 1.9 meters. If we now again show the obstacles, we will this time see that the whole mezzanine is an obstacle since it is not taller than 2 meters. So as long as an obstacle is at a higher height than 2 meters, a worker will be able to walk under it. In terms of computing power, we should always keep in mind that the more obstacles we have in our frame, the more possible routes and corner points we can have. This in turn means that plant simulation requires more computing power to calculate the shortest paths between objects. Now we will switch to a second model. In this model, we want to import a graphic. To do so, we click on Import Graphics in the Edit ribbon. Then we select the graphic that we want to import and place it in the frame. We could also just drag and drop the graphic into our model frame. Then we leave all settings as they are and press OK. If we now show the obstacles, we can see that the whole graphic is one obstacle. However, this is not what we want. Therefore, we open the Show Graphic Structure dialog. Here we can see that all objects have an individual graphic when we select them. So what we rather want is that each graphic should be an obstacle. As we've seen before, we can change this in the Edit 3D properties of the Factory node. So we open them. Then we switch to the Graphic Settings tab and change the obstacle to Graphics and click OK. If we now close the dialog and show the obstacles again, we will see that each object is an obstacle. If you now have objects which shouldn't be an obstacle, you can go through the objects in the graphic dialog and set them individually as no obstacle. Let's assume that we do not want the shelves, which are the 8th object, to be an obstacle. Then we could select them and open their Edit 3D Properties window. In the graphic settings, we could now set the obstacle to none. If we now show the obstacles again, we can see that they are no obstacle. As you may notice, the suspension railroad is also no obstacle. The reason is that it is higher than 2 meters, which can be looked up in the Edit 3D Properties window. So if you import a graphic and the workers aren't able to walk under the objects, you should always consider to look into the height of the objects. Depending on your needs, it might be annoying that the whole graphic is selected when we click on the floor. Therefore, we can simply delete it. To do so, we select it in the graphic structure and delete it. In this way, we will also see our grid instead of the floor of the graphic, which might be more helpful when inserting objects. Now we want to insert a worker pool, a broker, a station with a workplace on the ground, and one station within workplace on another level. If we now show the obstacles, we will see that we have 2 different levels. The workplace on the second level is at 4.57 meters. However, the worker won't be able to reach the second station since it is on another level and we do not have stairs. Even though the graphic shows us stairs, these aren't stairs that are recognized by Plant Simulation. These are just a graphic. So now we have 2 options. Either we insert a stair that rises to the level of the workplace, or we use a footpath. To use a stair can be redundant since we have already a graphic of stairs. Therefore, we use a footpath. Here we should now take care that the footpath starts before the obstacle, so the worker is able to walk along them. Then we should enter an anchor point height of 1 meter and continue the footpath. To reach the level of the workplace, we know that we need a height of 4.57 meters. So we set the anchor point height to 4.57 meters. Before starting the simulation, we will first open the event controller. Then we switch to the settings part and deactivate skip long event intervals. Since the worker has to walk a long distance, the event would be fast-forwarded. However, we want to see how the worker walks on the footpath in normal speed, therefore we need to uncheck skip long event intervals. Now we start the simulation and we'll see that the worker is able to reach the second workplace. You might not want the footpath to be visible, therefore we can open the Edit 3D Properties window and switch to the Graphics tab. Here we can now deselect Visible and click OK. The footpath is now not visible. However, you might want to edit something in the footpath afterwards. Since we turned off the visibility, we can now access the footpath by right-clicking in the frame and selecting Show Structure. Here we can now right-click the footpath and select Edit 3D Properties. Then we can again make the graphics visible. So in the second example, we have shown how to handle imported graphics and how to use footpaths in them. This concludes our video on obstacles.